Our objective today, I can use measures of center and spread to compare data sets. Critique and explain. The prices of paintings sold at 2 galleries in the last month are shown. Stacy and Diego both have paintings they want to sell. So we have the information for Gallery 1 and the information for Gallery 2. Stacy wants Gallery 1 to sell her painting because it has the highest sale price. And we can see that in Gallery 1, the maximum value is $15,000. While in Gallery 2, the maximum value is $3,500. Diego wants Gallery 2 to sell his painting because it has the most consistent sale price. So Diego is focusing on what's more consistent, while Stacy was focusing on the highest sale price. Do you agree with Stacy or Diego? Explain your reasoning. When we look at Gallery 1, the minimum value was $500. So if I was looking at the range for Gallery 1, the range would be those $15,000 minus $500, and that would give me a range of $14,500. This is for Gallery 1. For Gallery 2, the range goes from $3,500 being the largest or the maximum amount a painting was sold, and then the minimum value is $2,750. So that means that our range is $750. So in this case, even though Gallery 1 sold a painting for a lot more money, I would agree with Diego, because in Gallery 2, at least I know what I would be getting for my painting, since the value is more consistent. While on Gallery 1, I would probably end up getting one of the lower end values, or maybe at max 1,200. This maximum value seems to be an outlier. So I agree with Diego. The prices in Gallery 2 are more consistent. B. Reasoning. What reasons could there be for the differences in sale prices between the 2 galleries and for the outlier in Gallery 1? Well, I'm thinking that Gallery 1 is probably showing or showcasing new artists. And Gallery 2 could have paintings of artists that have sold paintings before. That's why the prices are a little bit more consistent. Habits of mind. Make sense and persevere. What is the mean sales price for the paintings at Gallery 1? And what is the mean sales price for the paintings in Gallery 2? So remember, to find the mean, we add up all the values and then divide by the number of values that there are. So go ahead and do that. Okay, for your mean for Gallery 1, you should have ended up with 3,133. And for Gallery 2, you should have 3,030. Example 1. Compare data sets displayed in dot plots. It says the mean fuel efficiency for the cars represented in the dot plot is 40.25 miles per gallon. The MAT for the cars is about 2.94. How does the outlier in the data set affect the mean and the MAT? We haven't talked about the MAT much, but remember that the MAT is just a measure of variability. MAT stands for mean absolute deviation, so it measures the spread around the mean. We know that when we have an outlier, the outlier is always going to pull the mean towards the side where the outlier is. In this case, the outlier is on the right, so it's going to pull the mean to the right. And if the mat is based or centered around the mean, the mat is also going to be pulled to the right. The outlier will pull the mean and the mat values to the right, making them a bit bigger. Compare data sets displayed in box plots. The table gives an analysis of random samples from 2 high schools of amounts their students raised during a charity fundraiser. How do the ranges of the schools compare? How do the interquartile ranges compare? What does this mean in terms of money raised in each school? So we have the information for Caitlin's High School, and we also have the information for Phillips High School. I recommend that we can create box plots on the same one for both of them. I can see that both of them have the same minimum value and they both have the same maximum value. So to make it easier to compare, right here on the side, I'm going to create one number line with the 2 box plots on the same number line. Okay, I'm going to do Caitlin's High School first. So I know that my minimum is at 25. The maximum value is at 68, which is going to be about here. The first quartile is 32. The median is 45. And the third quartile is 52. I know that Q1, the median, and Q3 make the box. So I have my first box plot. Now that's going to be Caitlin's. Now I'm going to do Phillips. Minimum of 25, maximum of 68. But the first quartile for Phillips High School is 45. And then the median is 50. The third quartile is 56. I know that Q1, the median, and Q3 make up the box. And now we can see the spread. So when we compare these, I can see that 75% of the students in Phillips High School collected more than $45 each. While in Caitlin's High School, half of the students collected less than $45, while the other half collected more than $45. So let's start doing some of these comparisons. It says, how do the ranges of the 2 schools compare? Since both schools have the same maximum and the same minimum, the range is the same for both. Now the interquartile range, on the other hand, remember that the interquartile range is the distance between Q1 and Q3. And I can see that for Caitlin's High School, the interquartile range is a lot bigger since this spread is wider. While the interquartile range for Phillips School, it's smaller since this range right here is a lot smaller. It's less wide than this one. The IQR is higher for Caitlin's High School than Phillips High School. Now remember that in a box plot, each one of these segments, or it divides the data into 4 equal parts. So each of these segments is 25%. And when I look at this 45 here, since they both share a 45, in Phillips High School, 75% of the students collected $45 or more, while in Caitlin's High School, only 50% of the students collected $45 or more. So like I said, 75% of the students in Phillips High School raised $45 or more each, while only 50% of the students in Caitlin's high school raised $45 or more each. Now, we do not know which school collected more money, even though it seems like the school in Phillips High School would have been the one that collected more money, because they are the ones that 75% of them collected more than $45. However, it's talking about a random sample. We do not know how many students participated in this fundraiser. So these percentages are dependent on the number of students that participated in the fundraiser. We do not know the number of students that participated, though. So we cannot make an assumption as to which school raised more money. Habits of mind. Use the appropriate tools. Does the information given by a box plot allow you to determine the mean of the data set? Remember that the box plot only gives me the 5-number summary. So that's your minimum, Q1, the median, Q3, and the maximum. With these values, we can find the interquartile range, and we can also find the range, but we cannot find the mean because we do not have the individual values. We cannot find the mean because those individual values are not given. Compare data sets displayed in histograms. Now keep in mind that the histograms give me the frequency, so I am going to be paying attention to the frequency, and then I'm going to pay close attention also to the intervals. It says the histograms show representative samples of the ages of viewers of 2 shows. So we have show 1 and show 2. If a marketing team wants to advertise a product that is targeted at adults between the ages of 25 and 34, during which shows should they advertise? And then they want me to explain. We're focusing on the ages between 25 and 34. So those are the intervals I'm going to be paying attention or focusing on. 25 to 34. So let's look at this frequency. In show 1, people between the ages of 25 and 29 are going to be 8, and then from 30 to 34, that's 10. So in this case, for show 1, the total number of viewers would be 18. For show 2, viewers between the ages of 25 and 29 are 5, and then between the ages of 30 and 34 are 4. So my total viewers for show 2 is 9. So in this case, they should choose show 1. Because it has a higher frequency within that interview or within adults of that age. Now for show 2, viewers between the ages of 25 and 29 is 5. And between the ages of 30 and 34 is 4. That means the total number of viewers within this age range is 9. Now, if they want to advertise something for this specific population, they should go with show 1, because show 1 has a higher number of viewers of adults between the ages of 25 to 34. Make observations within data displays. The box plots represent data Nadia collected from classmates, and we have the average number of texts sent on school days and the average number of text sent on non-school days. Provide a possible explanation for each of the observations that was made. So let's look at the first one. Students sent far more text on non-school days than on school days. What can be a possible explanation for that? Okay, so one possible explanation, students cannot use their phones during class. And after school, they're either working on homework or maybe some after-school activities. Let's look at observation number 2. There is more variation in the number of texts sent on non-school days than on school days. So we can look at that variation. Remember that our measures of variation are going to be the range. So we can see that the range is smaller during school days than on non-school days. On non-school days, our variation is 80, while on school days, the variation is 27. Another measure of variation is our interquartile range. So we can see that our interquartile range here seems to be about 13. And then our interquartile range here goes from 40 to 60, so that's going to be 20. So this interquartile range is wider than the one for school days. So once again, some of the reasons or possible explanations for this would be just the amount of access that students have to their phone during the day. Now the last observation says, one person does not send any text on non-school days. This represents an outlier because it is far from the other data values. So what is the possible reason why we have one person not sending any text? They don't have a phone. So I'm just going to put right here A3. Possible explanation. There are students without a phone. Or at least one student. There's at least one student without a phone. Okay, make 2 other observations about the data that Nadia collected. So we can see right here, the maximum is 80, while over here the maximum is 26. We can also notice that the median here is 50. While the median here is 17. You can also make other observations based on Q1 and Q3 for both of these data sets. Does the type of graph that you create with a given data change the observations that can be made from that data display? Explain. And remember that the answer is yes. Not all of these data displays give us the same information. A dot plot gives us all the data values. We can see the minimum, maximum, mode, and we can find the mean, the interquartile range. We can find all the other values. So that's for the dot plot. The box plot provides the 5-number summary. But we cannot find the mean from here. The histogram shows the frequency of different intervals. And the shape of the distribution. Do you understand? How can you use measures of center and spread to compare data sets? Measures of center show how closely the data is clustered, while measures of spread show the variability of the data. How are the MAD and the interquartile range similar? How are they different? They are both measures of variability. The interquartile range measures spread from the median, while the MAD measures spread from the mean. When comparing two sets of data, it is common to look at the means. Why might the MAD, the mean absolute deviation, be a useful piece of information to compare in addition to the mean? Remember that the mean absolute deviation shows the spread from the mean. So if the number is big, if that means it's going to have a larger variability and there might be an outlier. It will show how close the data is to the mean. If the value is big, there might be an outlier. Error analysis. Darius says that if the minimum and maximum values of two data sets are the same, then the medians will be the same. Is Darius correct? Explain. And the answer is no. Remember the last two sets of data here that we were comparing with these. They had the same minimum and the same maximum, but that didn't mean that their medians were the same. The median is the middle value. If two data sets have the same maximum does not mean that it will have the same median. It's a possibility, but it's not a guarantee. Do you know how? You're going to be using these two data sets, data set A, data set B, and then you're going to find the means because you need to compare them. Do not find the MAD. We did not work on finding the MAD, so skip that part. Answer question number 7. How do the medians compare? How do the interquartile ranges compare? And which measure of center and spread are better for comparing the data sets, A and B? Make sure that you guys explain. Okay, I have all my data values here. Question number 5 says, how do the means compare? Set A. Set A is higher. At 87. While set B has a mean of 83.2. How do the medians compare? The medians are the same. For both. How do the interquartile ranges compare? So we're going to compare set A and set B. Remember that it's Q1, Q3, take away Q1. So for set A, Q3 is 90 and Q1 is 83. So 90, take away 83. That leaves us with 7. And then the interquartile range for set B, Q3 is 88 and 80. So 88, take away 80, and that would give us a value of 8. The interquartile range for set B is higher. Now, which measures of center and spread are better for comparing the data sets? Since the means are different, but the medians are the same, then the best way to compare these data sets would be to use the median as our measure of center, and then compare them with the spread. How far away are these values from the median? So we would use the range and the interquartile range as measures of variability.